Today, we're going to crack open the surface of our planet. Seriously, we're diving deep to explore the massive hidden forces that are constantly sculpting everything we see, from the tallest mountains to the deepest oceans. These forces are also behind some of the most powerful events on Earth.
It's a fantastic question, right? I mean, the ground we walk on feels completely solid, stable. And yet, we know it can be a hotbed of unbelievably violent activity. So how is that even possible? Well, the answer is all about something called plate tectonics.
You see, the Earth's crust isn't one solid piece, like an eggshell. It's actually shattered into these enormous interlocking slabs called tectonic plates. The best way to think about it is like a giant jigsaw puzzle that covers the entire globe, except this is a puzzle that's always moving, always shifting around.
So what's making these giant puzzle pieces move? Deep inside the Earth, the rock of the mantle is so hot, it behaves like a super thick, churning liquid. It's kind of like a pot of water boiling in super slow motion. And these slow, powerful currents act like a massive conveyor belt, dragging the plates on the surface along for the ride. And when I say slow, I mean it. They move at about the same speed your fingernails grow.
Okay, so this constant movement leads to 3 different ways the plates can interact at their edges, or what we call boundaries. Let's start with the first type, divergent boundaries. This is where plates are actively pulling away from each other. And this is a really incredible creative process. As the 2 plates pull apart, they open up a gap. Right away, hot magma from the mantle rises up to fill that space. It then cools down and hardens, forming brand new crust. This is why we call them constructive boundaries. They are literally building new parts of our planet's surface from scratch. You can see this happening in 2 main places. Deep under the oceans, this process creates gigantic underwater mountain ranges, like the famous Mid-Atlantic Ridge. But it can also happen on land. Just look at the East African Rift Valley. It is literally tearing a continent in 2, and one day it might even form a whole new ocean.
So if plates are pulling apart and making new crust in some places, it kind of makes sense that they must be crashing together somewhere else, right? And that brings us to our second type of boundary, the convergent boundary. This is where tectonic plates are on a direct collision course. But here's the interesting part. Not all collisions are the same. What happens in the crash depends entirely on what kind of plates are colliding. Is it a dense, heavy oceanic plate hitting a lighter continental plate? Or 2 ocean plates? Or 2 continents? Each one creates a totally different outcome.
And here you can see the 3 incredible results. So when a dense oceanic plate crashes into a lighter continental one, it gets forced to dive underneath. And we call that subduction. And that process creates huge volcanic mountain ranges like the Andes. Now, if 2 oceanic plates collide, one of them will dive under the other, forming chains of volcanic islands like Japan. And finally, the big one. When 2 massive continents collide, neither one gives way. They've got nowhere to go but up. They buckle and crumple, forging these absolutely colossal mountain ranges, like the Himalayas. And this process, subduction, is exactly what fuels the infamous Pacific Ring of Fire. It's this huge arc of volcanoes and intense earthquake activity. And it's all a direct result of those oceanic plates diving beneath the continents all around the edge of the Pacific Ocean. All right. We've seen plates pull apart. We've seen them crash together. So what's the third option? Well, they can also just slide sideways right past each other. And this happens at what we call conservative boundaries, sometimes also known as transform boundaries. And this is what really makes this boundary unique. You see, crust isn't being made and it isn't being destroyed. Instead, the 2 plates are just grinding against one another, building up an immense amount of friction and stress that just keeps growing and growing until it reaches a breaking point. And when all that built-up stress is finally released in a sudden jolt, well, that's what an earthquake is. The most famous example of this, of course, is the San Andreas Fault in California. It's a massive conservative boundary where the Pacific Plate and the North American Plate are locked in this constant slow-motion grind. So, we've looked at the 3 types of boundaries one by one. But now let's zoom out. Let's see how they all fit together to form this single, incredibly dynamic global system. When you actually map these boundaries across the globe, these really clear patterns just pop out. You see the divergent boundaries, the creative ones, running like seams right down the middle of our oceans. Then you see the destructive, convergent boundaries framing the edges of continents, and the conservative or transform boundaries. They often act like connectors linking the other types of boundaries all together. So the crucial point here is that these aren't just isolated events happening randomly.
They form one single, dynamic system that shapes our whole world. The creation of new crust at divergent boundaries is basically balanced out by the destruction of old crust at convergent ones. It's this powerful, elegant engine that's responsible for the very architecture of our planet.
And that engine is still running, right now, as you're watching this. Which leaves us with a pretty fascinating final thought. The same forces that built the Himalayas are still pushing continents around today. So, where do you think the next great mountain range on Earth is slowly but surely being built?